Hello curious mind, welcome to our space lab.
In this episode, we'll learn how we can use a thermal resistor, also known as a thermistor, to measure temperature. We'll learn how to calculate the resistance of the thermistor using measured voltage and how to transform it into temperature with the Steinhart-Hart equation. Sounds difficult, but it's just a little bit more math than usual. Let's get down to business.
For this, we would need the breadboard, the microcontroller, the thermistor, in this case a 10 kilo thermistor, a resistance of a similar value to the thermistor, in this case a 10 kilo ohms, an LED of your choice, and 5 connecting wires. Thermistors are variable resistors. They change their resistance based on temperature. In my hand, I have a negative temperature coefficient thermistors, which means that as the temperature increases, the resistance decreases. There are also positive temperature coefficient resistors, or PTCs. These decrease their resistance with decrease of the temperature. So how this works is that a thermistor has a semiconducting material which has free charge carriers. These charge carriers are responsible for the current flow. For a NTC, as the temperature increases, the number of free charge carriers present inside the semiconducting material increases as well, which results in a higher current flow. In my hand, the NTC also works in the same way as detecting the temperature, and this gives out a voltage value to your Arduino, and this reads as the temperature which is being sensed by the thermistor. Let's see how the connections are done. Connect your thermistor to 5E and 7E. Make sure that the positive of the thermistor is connected to the positive powering line. Otherwise, you have a possibility of burning the thermistor. Connect a similar value resistor, in this case a 10K resistor, to 7D and 11D ports on the breadboard. Connect a red LED to 20E and 22E on the breadboard. Connect a red wire connecting the thermistor at 5B to the 5 volts on the microcontroller. Connect a blue wire from 11B, which is also connected to the resistor, to the ground on the microcontroller. Connect a blue wire from 7B, which is connected to the negative of the thermistor, to the analog port A0 on the microcontroller. Connect a red wire, which is powering the LED, from 20B to the 5 volt port on the microcontroller. Connect a black wire connected to the negative of the LED from 22B to the ground on the microcontroller. Let's see how the coding is done.
How can we measure the temperature if Arduino only measures voltage between the thermistor and the resistor? Well, first we will find out the voltage and then use the voltage divider and the known resistance of the resistor to solve the equation for the thermistor. Here is a voltage divider equation. Now that we've found the thermistor resistance, we can use it with the Steinhart-Hart equation to convert the resistance into temperature. If you want to do it properly, then you'll need to find out the coefficients by measuring resistance at different levels. In other words, calibrate your thermistor. But as they're all very similar, we'll just use typical coefficients. Now let's try using our knowledge in the sketch. First, we define a variable to hold the measured voltage. You will also need some variable for our Steinhart-Hart equation. These are some constant values, which we'll copy and paste. In the setup part, open the serial connection. And in the main loop, read the voltage value from the thermistor. Then calculate the corresponding resistance and convert it to temperature in Kelvin using the Steinhart-Hart formula. Afterwards, you can also convert it to Celsius, or if you wish, to Fahrenheit. In the program, you will see in the serial monitor you get the temperature in Celsius. Finally, let's use the measured results in action. First, let's add a variable defining the LED pin. Then, in the setup part, define LED pin as output. And in the main loop, let's write a simple if statement. If the temperature is higher than 24 degrees Celsius, turn on the LED. Else, keep it turned off. Run the program and voila! The LED is on because you are on fire. Here is a task for you. Try reproducing this little experiment and convert the temperature to Fahrenheit. If you have any cool ideas, share them with us in the comments below, and we'll try to come up with some projects for our future episodes. Subscribe not to miss the next episode from our Space Lab. See you in the next video.